Our goal is to talk about questioning skills and how to improve and increase student engagement with questioning. And so if you take a look at your sheets, look at the side that has the exit ticket and takeaway questions on it rather than the graph, so flip it over. Before you can get to questioning to improve student engagement, you have to teach a lesson. And so what Luann and I are going to attempt to do today, I'm going to work through a language arts lesson, and then I'm going to explain how I would use questioning skills at the end of it to hopefully enhance, improve, increase student engagement. She's actually going to do a demonstration, a science or a lab demonstration, and then you will be her students. So we're glad Duff's here and Mrs. Bundy. We'll see how that goes. We'll see how those sharp science skills come out. But we're going to try and have you act as those students, those high school students, so we can model the chaining and some of the things we're going to do. If you look at takeaway or exit ticket questions, oftentimes if you tell kids they're going to have something at the end, they will stay better engaged. You know, if there's an expectation at the end and they know they're going to have to turn something in. So those takeaways can either be a question they ask you, the exit tickets can be something you ask them, it can be a little sticky note that they hand in, or it can be some kind of half sheet of paper. It doesn't have to be anything big or long. You just want to flip through really fast to find out, you know, what they understood about the day's lesson and how engaged they were. So those are things you can do. Okay, in terms of then that next part, the types of questions. In language arts, it's 1216J that the questions are addressed. And when we talk about language arts questions, I use these terms because of 1216J. Luann uses Bloom's taxonomy. It's really basically the same thing. When we talk about literal questions, they're questions with one right answer. What did you have for lunch today? What kind of car do you drive? Are you going to the game tonight? We talk about interpretive. When you interpret information, you have to have something to go on. So whether it's the story or you're interpreting something about your essay, paper you wrote, those are ways that we interpret information. And then inferential, which, you know, again applies to science. You're inferring, you're creating a hypothesis, you're predicting, you're trying to figure out. And then critical questions. And critical questions take in all of this. Synthesis and evaluation and analysis. And we kind of talked a lot. You know, it was great because we had a lot of conversation during the process of planning today. We talked about how evaluation and synthesis can be switched. We both kind of feel like synthesis is really probably the highest level of thinking. But anyway, analysis, you tear apart and look at the parts, you tear apart as a whole. Evaluation is you place some kind of value on it. You have some kind of critique of it. And then synthesis is pulling together a couple of different ideas into one, which we think is probably the highest level. But again, all of student engagement is improved if kids are at these higher level thinking skills. Because if they're just here, they don't have to think that hard, and they don't have to stay quite as engaged. So our goal then is to get into those higher level thinking skills as much as possible. And that's why we wanted to identify, those types of questions. Okay, if you look at then the chart, I took this off of Edutopia. This was Rebecca Olber's page, and actually she asks those 5 simple questions. I thought it was very applicable for us because it could be used from K through 12. Any of those questions could be used for any content, for any grade level. They're really simple. I'm not going to read it to you because you can read it. But I think you'll see that, you know, just even if you had this up at the front on your table or somewhere, just as a reminder to keep trying to get kids to think for themselves. I think sometimes as teachers we, you know, want to give them the information, but the idea is to keep them engaged, is to keep them thinking and absorbing that information. So my goal then is to talk about low expectancy students, and I want to make sure every one of my kids today is engaged in the lesson. It's part of my plan. According to Marzano, that's one of the important things we do. So I'm going to review elements of fiction with the use of the story of the tortoise and the hare. Now you probably all are familiar with the story of the tortoise and the hare, but some of my students aren't, and I know that. So I'm going to do a quick retelling of the story of the tortoise and the hare, just to remind everybody how this story goes. And again, my goal is to talk about elements of fiction. So we're going to talk about protagonist and antagonist and theme and some of those pieces that fit with elements of fiction. So we have the hare, and he's in blue, so he's probably easy to cheer for, even though he's not really true blue or blue jay blue. But he's very arrogant, very conceited, very vain, pompous, presumptuous, that kind of a character, because he knows he's really fast. And we have this sweet-natured, kind, loving little turtle here. Well, the hare knows he's really fast, so because he wants to show how great he is, he challenges the turtle to the race. The tortoise says, yeah, I can do that. I can do that. I can try. I'll give it some effort. So the turtle agrees. I'm gonna try and do this thing. So all the woodland animals hear about this, and they're pretty excited, and they come and they gather around, and they're gonna watch the big race. And you've got the fox and the squirrel over here, and they're talking about betting, and the fox is sly. So he's going with the turtle because he's thinking big payout if the turtle wins, right? Okay, so they're all excited about this. Okay, the race starts. The hare takes off. Can't even see him anymore. Just shoots off like a rocket. Not our little turtle though. He's not quite as fast. He's gonna try and get going. Oh, there he goes. There he goes. There he goes, and he goes, and he goes. And the thing is he doesn't have quite near the ability to run fast, but he's got effort. He's got effort, and he's got perseverance, and he's determined, and he's gonna try his hardest. So he keeps going, and he keeps going, and he keeps digging. Pretty soon, the hare's so far ahead, what does he do? What does the hare decide to do? He's gonna take a nap. Looks around, can't even see the turtle. I'm just gonna go over here, crawl in these nice soft leaves and take a nap. So he does. But here comes our turtle, slow and steady, keeping that same pace, working at it, trying his hardest, giving that effort. Eventually he crosses a sees the hare sleeping, just keeps on going, crosses the finish line, the hare wakes up, oh no, realizes the turtle's nowhere in sight, goes shooting for the finish line, and boy is he humbled, because he realizes that he did not use his talents to the best of his ability, but the turtle did. So then, okay, I've told the story, and then I'm going to talk to the students about protagonists and antagonists. Now in English, we talk about the protagonist has a goal to achieve or a problem to solve. They might argue that it's the turtle, it's the protagonist, because a lot of times they like to think it's the good guy, right? So it's the protagonist. But actually, the turtle is static. That character didn't change, but the hare did. He's our dynamic character. He's the one who changed and had the realization. And the protagonist is the vehicle for the theme that the author uses. So I can use that example, and we can talk through that. And all of this will bring me to these interpretive and inferential questions, these higher level thinkings. Questions, because I can stay here, but remember I'm working on student engagement, and I know to get to good, solid, strong student engagement, I've got to get kids thinking for themselves. So then I'm going to ask them about theme, and again, I'm just telling you how this looks the way I don't use you as students. They're going to say slow and steady wins the race, or slow and steady pace wins the race, and I'm going to say, but that's a cliche. Someone will say hard work pays off, and I'm going to say that's a cliche. So I'm going to ask them, force them into saying it in their own words. I mean, they need to say it in their own words. So they need to somehow come up with the idea that because the hare, didn't use its talents, but the tortoise did, the tortoise ended up winning. So they need to explain that. And the other thing I can do to get them to interpret, to infer and to interpret, is to say, well, what if the hare had won? How does that change the story? So those are different things I can do to help get them to those higher level thinking skills. And it actually really does work. And then with chaining, the other thing I really like to do with chaining is, if I ask Lori a question and she answered it, and she did, a brilliant job, I'm going to say, okay, I'm going to acknowledge that question, and I'm going to say, let's move on and think about that. And then I might go to Brian and say, what could you add to that? And that's what chaining does for us. And so we want to include every student. And the one thing, you guys, that I really want to leave you with before Luann gets going is to create a culture in your classroom as quickly as you can that every student has a voice. You've got those low expectancy students, you know they're not as confident, they're not as comfortable, they're not as willing to reach out, and they're not gonna be the ones with their hands in the air. But we want to hear their voice all year long. And so the sooner they're comfortable in your classroom, the more likely they're gonna get involved. And sometimes you do need to use literal questions for them so they are more confident, but eventually you'll find that they can be asked those more difficult, higher level thinking questions, because as they become more confident in their ability to share.
Mrs. Rogers to the office, please.
And to be engaged.
Rogers to the office.
They're more likely to become a part of that. So, does anyone have any questions for me? Okay, I'm gonna pass it over to our science teacher and she's gonna do her demo.
Okay, so I think the reason Brad asked me to do this segment on questioning, this was my learning goal several years ago. And I wanted to improve my questioning. I just felt like I was rushed every period. It was like rush. And I wasn't asking enough higher level thinking questions. And a lot of times I wasn't even getting to closure. The bell would ring and, I would lose the kids. And I didn't know if it was coming from, I taught 90-minute periods before, and now I'm in 45, so I'm hurrying, or if I'm just older and slower that I'm doing this now. So I decided to look at some different models, and I took a class from UNL. And I liked it, they just gave some really simple, concrete things you can do. And I posted them on the board over there. And the first thing I wanted to address for my learning goal was higher level thinking questions. And we know when we're doing a lesson, we can't write out all our questions. That's going to be impossible. We wouldn't even know which direction to take. And so they just suggested that you just write 1 or 2 with each lesson. Simple, easy to do. You have something planned that would maybe bring them up on Bloom's taxonomy, maybe to an application, an analysis, or a synthesis level question. So when you are rushed, you don't have time sometimes to pause and say, let's see, how can I bring this to another level? You've got it there, you can ask the question. I like that. It's helped me with my lessons to kind of put in some higher level questions. The second thing I learned from the class that I was doing wrong was how to respond to their answers. I would always say, oh, good answer. And they're saying, no, that's not an effective way when you're questioning students to respond. You shouldn't evaluate their answers. You should acknowledge their answers, but not evaluate them. So instead of saying, good answer, Lori, I should say, thank you, Lori. Move on to the next person. Or if they said the water is boiling, yes, the water is boiling, move on to the next person. And the reason, the research and data behind that, the first part of it made sense to me. They said, well, that's because if you say yes to one student, you go to the other student, you say, good answer. Well, the student you just said yes to now thinks their answer is not as good. They shut down. They aren't going to engage anymore. Okay, and that kind of made sense to me. The one I was surprised at, the research showed the one I praised also shuts down. Because a lot of students are seeking outside reinforcement. They're not learning for the sake of learning. So once I've said to you, really good answer, they're thinking, okay, I did my job today, I got my praise, I'm done. So that surprised me, but it reduced engagement. So I really have to focus on using that. I still encourage myself a lot of times, good answer. I should say thank you. So that was the second thing I learned that I thought was interesting. And to show how this works, I'm going to do a lesson segment from Marzano, and I'm going to look at design question 4 and 5. And design question 4 is engaging students in cognitively complex tasks involving hypothesis generation and testing. Marzano design question 5 that we're going to model with this lesson segment is on engagement and engaging students by presenting unusual or intriguing information. To do this, another questioning technique like Janice had mentioned is chaining. And we'll look at how we can do that. So for my demo, I'm going to have a discrepant event. It should make no sense. So right now I just filled this flask with water. I have it sitting on the hot plate, and it's going to start to boil. So then I would ask the students to make observations. I love the sticks because everyone is accountable at every question. And little girl can't hide in the background, and you can't have, oh, you always pick on me for the hard questions or the easy. It's just random. So I like sticks with my students. Of course, guys, I'll just count on you to volunteer. So the first thing I would ask them to do if they're going to generate a hypothesis is they have to make good observations. So I'd say, okay, what is one observation you can make?
Steam coming out the top.
Okay, correct. You can see steam coming out of the top of the flask.
Starting to boil.
Okay, thank you. It's starting to boil, so you can see the water boiling. Anything else you observe?
Condensation.
Okay, there's condensation forming. And so you have to make these really good observations to figure this out, because this isn't going to make sense. Anyone have anything they would want to add to that?
It's not full.
It's not full. Okay. And I hope it's boiling enough, but we'll give it a shot. And so then what I'm going to do is I'm going to stopper this. I'm going to create a closed environment. Had a little mishap earlier, so I'm going to make sure I duct tape this one really well. Seal this. Okay. And then with any good hypothesis, it should also be based on prior knowledge. So what else do you know that you could add to this that might help you figure out this demo when we get started? You know anything about water
Well, you-
temperature? What?
You're not applying heat anymore.
Yeah, we
So it
moved
will
the heat.
stop boiling.
So it's not boiling. So what do you know about the temperature of boiling water?
100 degrees Celsius.
It's 100 degrees Celsius. So obviously the temperature in here must now be right, and probably just a little bit less because it's not boiling much right now. So we know that. Anything else you can think of you know about heat, energy, matter that may help you solve this discrepant
The
event?
atoms are going to be moving faster when it's hotter.
Okay, the atoms are going to move faster when the temperature is hotter. That's correct.
Atmospheric pressure influences boiling.
So atmospheric pressure influences boiling. So does anyone want to add to how that's going to affect this? Ideas? Okay, so now we'll see what happens. If I want to get it to boil again, what would you suggest I do?
Heat it up.
Heat it up and it would boil again. What if I told you that I can actually boil water with ice? Would you believe me? You don't always believe me. And so we're going to test this to see if this will work. And so I'm just going to take the bag of ice, set it here on the flask, and make careful observations, and then you're going to form a hypothesis as to why this discrepant event occurred. Oh, it's boiling. And so you can see the bubbles start to form. We'll get going pretty good here in a minute probably. So it's boiling. So ice made the water boil. So if I asked you to form a hypothesis, and we'll use the chaining concept, I would go around to ask the students, give me an idea. What do you think is happening here? Have any ideas?
The change of temperature definitely caused something to happen.
Okay, so good. The change in temperature caused something to happen. How would you elaborate on that?
Discrepancy, the difference is drastic, and it was made more, such a varying degree of temperature change.
Right, and there's going to be a big difference in the temperature change where?
When the ice is added at the top,
Right, when the ice is added to the top.
It got colder in there, so the molecules slowed down, which reduced the pressure in there.
Okay, good. So it cooled in the flask, so the molecules slowed down. So it reduced the pressure. Where do you think? Why is it boiling?
Inside the flask.
So you're saying that we reduced the temperature of the particles above the water. It slowed the particles down. That reduced the pressure on the water, so now the water boils.
Because heat moves towards the cool, is that,
And so if you were wondering if heat is moving toward the cooler substance, according to the laws of thermodynamics, they would say that was true. How would that affect this experiment? Is that a factor, and how could you test that? So then, if you had time, you could go with that, and they would actually move up to a higher synthesis level question. Can you think of an experiment, which sometimes I do, and then they want me to run it again, and they want me to put the ice here, or they want me to run it again and tip it the other way, and then we experiment that way with it, which is really good. The part that you really have to stress that I always ran out of time with was closure, because if I don't really stress the correct answer, and one student would say, the moon is made of cheese, haven't clarified that when I give a test, 4 kids are going to write down the moon is made of cheese. So I thought I have to get better on closure to really bring it back to the point I want to cover. So I'd have them pair and share, and then describe how reducing the temperature of the air above the water slowed down the air molecules so they exerted less pressure on the water, so the water actually would boil at a lower temperature because of the reduced pressure. I would share it, maybe I'd have them write it down, to make sure they had that correct. And then, of course, they would share if you're a volunteer. And then finally, an application like I planned ahead of time so I could take it to the next level. Okay, now that we understand this concept, I say, okay, here's your mac and cheese. You're going skiing this weekend. You're going to cook a little mac and cheese in the mountains. How's that going to work for you? And so now they're going to have to apply this to a different situation. Again, engages them because it's something they're familiar with. And then I would say, is the water going to boil sooner? Is it going to boil later? Is it going to be hotter? Is it going to be colder? Are you going to have to cook the mac longer or shorter period of time? And so, they would have to use this concept in that application. So planning ahead kind of helps with that. And then finally, like Janice said, you might want to add to it, is that I would have them do an exit ticket. And so they would write down anything you weren't sure of, any questions you might have, or something you clearly understood. Post the exit tickets.
And we were really trying to be conscientious of time because you never know how it'll go. But with my lesson too, I could apply it to, how can this theme of hard work pays off apply to you? And there's another way they can actually take, and interpret that, like the mac and cheese idea too. Okay, so if I try my hardest all the time, eventually, I will be successful. So that's kind of our goal. But our exit tickets for you guys are to decide whether or not you felt like a smarty or a dum-dum today. So we would like for you to enjoy a treat, and we thank you very much for coming. Does anyone have questions?
oh, very good, thank you, ladies.
Awesome.
Yeah.